AESolar, going to talk about shade resistant. Hamed, the floor is yours.
Thank you, Sharwan, for the kind introduction. Can you confirm that you can hear me?
Yes.
Okay,
And
perfect.
you can also see.
Okay, great. Then I will share my screen. So, can you see my screen?
Yes, yes.
Okay, perfect. So thank you, Sharwan, for the kind introduction, and I welcome everyone to this presentation of shade-resistant PV modules, which is also a kind of advanced module. Before going to technical presentation, I would like to give a briefing about our company. So our company is a customer-oriented company, and we are in the market since 2003. Since 2021, we are listed as a tier 1 company, which of course brings more responsibility, especially regarding to the quality of the module. This year, in AESolar, we received the PVEL trophy as one of the top performers in reliability and performance of our modules. Also this year, AESolar had a refreshment on logo and some structure due to 20 years anniversary of the company that we will be recognized with this logo from now on. I go briefly over our product portfolio. So our products can be categorized to utility and rooftop modules, and one module which is only dedicated to rooftop. So our Aurora, Comet, and Meteor series are our PERC heterojunction and TOPCon technologies with up to 700 watt peak for our heterojunction modules. And of course, here the modules can be offered with different sizes, but the main difference between the modules are the solar cell technology. However, we have some other modules in the portfolio. For example, the Terra module, which was presented this year also on TaiyangNews, is a module, a standard module, but with different interconnection, which brings more value in the sense of reliability and durability of the module, as well as energy gain. And it can be used for many different applications, which can be, so for example, agricultural, so agrivoltaic will be one of the noted ones. We also have one module for repowering project under the name of Repower, which can be used for repowering of existing projects to save the cost on other parts of the system. And finally, we have one module which is dedicated only for rooftops, and it's our Smart Participant Free module, which is a shade-resistant photovoltaic module. And I'm going to talk about this module today. So before going to the technical part, I would like to give you an overview on the market segments. If we look at the two biggest markets in Europe, considering the Germany as the biggest European PV market and the Netherlands as the biggest market per capita, we see over 60% of the installation in Germany and over 80% of the installations in Netherlands are rooftops. And of course, for a good reason. Rooftop installations are one of the major markets which secures the distributed and renewable energy. And of course, in the sense of flexibility, it can be used in different applications. Rooftop market, as I mentioned, is the king. But high demand for renewable energy, especially after gas crisis in Europe, has enhanced the niche PV markets. Some of these niche PV markets I can also categorize as a kind of rooftop, but as a kind of niche rooftop. So I would say that there will be like the building attached PV. So it should not be mistaken with building integrated PV. Here is just a standard module attached to the walls. And also balcony systems, which is being more and more popular, especially in Germany. But what are the challenges of rooftop PV? Rooftops are not always 100% exposed to the sun. The building elements can cast shadow, for example, considering the chimneys, cables, and antennas, as well as the trees beside the buildings. But also the urban structure can lead to significant shadows. So if you look at cities like this picture, that we have buildings with different heights and different orientations, Having a PV module on the roofs can be a big challenge in the sense of partial shading. We have also the climate and land specifications, which increase the probability of partial shading. So there is a big factor that we have to consider, and it's the limited area on the rooftop. We want to pack as many modules as we can on the module, but we have obstacles which induce shading over the PV modules. The second is a natural agent of shading, which is the snow, as you can see in this picture. And finally, bird drops or dirts can be also considered as a part for partial shading. So considering that PV modules are very sensitive to partial shading, it can lead to drastic power loss in PV modules. But it's just the energy point of view. In case that we have continuous partial shading, it can lead to reliability and durability issues, such as hotspot or in the worst case, fire. Here in this picture, for example, you can see a hot solar cell because of a shading of a leaf. But in case of the continuous shading, you're going to see burn marks or a hotspot, as you can see in the middle picture. And in very rare cases these days, we can also see fire on the roofs. And for this problem, we offered a new solution. And this is our smart hotspot-free shade-resistant module, which we have integrated bypass diodes for each individual solar cell inside the laminate. So the bypass diodes are integrated between the solar cells and ribbons, and they're protecting the relevant solar cell. So here you can see a schematic of the circuit of this module compared to an equivalent module, but with no extra diodes. So here we have one bypass diode for every single solar cell and 3 bypass diodes as the backup. For doing extra experiments with our partners, for example, Fraunhofer CSP, we designed an experiment to induce partial shading, artificial partial shading in lab environment on our modules. So we took 2 modules, one of them standard PV module and the other smart hotspot-free module with the same bill of materials and same solar cells. And then we shaded them with 2 scenarios of shading one solar cell and shading the bottom row. If we look at the shading scenario of shading one solar cell, we increase the shading in different steps in one direction. So if we look at the power loss, we see that the standard PV module loses power gradually until the bypass diode kicks in after 50% shading of the solar cell, and then the string will be completely bypassed. So here we lose about 1/3 of the module power. However, if we look at the hotspot-free module, it only loses 3% of the power, so it loses only one solar cell and of course the operating bypass diode, which leads to only 3% power loss, and the module operates at its 97% of nominal power. The second scenario is an extreme scenario. So here we shaded the bottom row of the PV module in 3 steps for each string. Here you can see that the standard module in each step loses 1/3 of its power, while the hotspot-free module loses the power gradually, and by shading the complete row, we lose only 20% of the power. So if we can compare the smart hotspot-free module under this shading scenario with the standard module, which loses the power completely, we have over 80% power gain compared to the standard module under same partial shading conditions. So in case that even if we want to compare this module with the standard half-cell module, we see that the standard half-cell module loses half of its power when we shade the bottom row. And if we compare it with our smart hotspot-free module, we still have 30% more power in this specific shading scenario. But we took the lab test even further, and we did outdoor tests in collaboration with one of our partners, Anhalt University. Here we mounted three modules in an outdoor test field of Anhalt University in Bernburg. We had one standard module, one shade-resistant module with the same bill of materials, and we had one reference module. It was a bifacial module, which was not shaded, to consider it as a reference module for control purposes. Then we mounted two planks in front of the module, which can induce partial shading during the day. We did the measurement for 6 weeks between October and November 2022. So you need to consider that here we had mainly low light conditions, which was not that desirable, but still we get really interesting results. The modules were connected to a Sol Connect IV tracer, and we measured the IV curve, irradiance, and backside temperature of modules every 10 seconds. So here in this picture, you can see the movement of the shade over the module, considering the positioning of the sun and the earth. And here in the left side, you can see the IV and PV diagram of modules in one specific point. Here you can see in this specific point, the standard module has lost 2 of its string and is operating at 52 watts, while the Smart Hotspot Free module is operating at 133 watts. So considering it relatively, it's 2.5 times more power compared to the standard module. And if you want to relate it to the reference module, it operates, there is a difference of 60% in maximum power. If you look at the PV curve in one day, considering one clear day without shading, we see almost the same curves from the modules. But in case of a clear day with shading, we see a very interesting result. We see that until 11 a.m., the standard module is working only with one string. And between 11 to 1 p.m., it operates with 2 strings. And again, it goes back to one string operation. While the Smart Hotspot Free has a very nice smooth curve during the day, which can deliver about 49% more power, or let's say more energy compared to the standard module. We also categorized to see the differences for different sort of days. We had checked the clear days, partially clear days, and cloudy days. And we checked the difference in energy yield. So here you can see that in clear days, the effect of shading was significant. So the standard module lost almost 50% of the power, while the Smart Hotspot Free module only 20%. But this value was very close to each other, although Hotspot Free module was still pioneering. In very cloudy days, the effect of partial shading was lower, which of course it's due to the light intensity over the module. So in total, again, we had over 25%, and in clear days, over 30% energy yield gain compared to the standard module. Here you can see a very interesting experiment with my colleagues. You can see that we have 2 modules. One of them is a Smart Hotspot Free module and the other standard module. And these modules are powering 2 water pumps. Now, in case that we are shading the modules, for example, for the standard module, you see after hitting the second string, the power is significantly lower. And after hitting the third string, there is no more power, while the Hotspot Free module is still producing power. So it shows the functionality of the module, especially considering the extreme shading scenarios of row shading for PV modules. And in case that even we consider more severe partial shading, not only shading 1 solar cell, 2 solar cell, or there are no, just standing people in front of the module, which is a significant shading scenario, you see that the standard module produces no power, while the Hotspot Free module is still powering the pump. But energy yield and power is not the only point. Reliability matters here as well. With collaboration with Fraunhofer CSP, we designed a test setup to evaluate the durability of the bypass diodes under partial shading conditions. For this purpose, we made a bias switcher and a current source to inject the current to the modules and change the bias of the PV module every 60 seconds for 10,000 cycles to induce stress on the bypass diodes to see how they are reacting in 10,000 cycles. So here in this picture, you can see the IR picture of the module when the module is in forward bias. So the solar cells are shining. And you can also see the picture of the module in reverse bias where the bypass diodes are shining. The module results is measured by a flasher and electroluminescence before and after 10,000 cycles. And as you can see in the electroluminescence picture and the IV curves, there is no power loss and there is no visible defects in electroluminescence test, which can ensure us of good durability of the bypass diodes for 25 years. But let's shortly talk about the economics. We have to consider that the customers buy PV modules in euro per kilowatt peak, so they buy the power. However, what they really need is the energy, so they need euro per kilowatt hours. In case that we consider the first part, you pay for the power and efficiency, and these are the determining factor. But in the second part, it's the energy and reliability. So in the first part, it doesn't matter how good is your PV module. As soon as it becomes partially shaded, you will lose significant amount of power, or in some cases, you have no power out of your module. However, with the smart hotspot-free module, you can gain in any cases a higher relative energy compared to the standard modules under partial shading conditions. And this brings a lower levelized cost of energy for this scenario. Considering the power optimizers versus shade-resistant PV module, there is also very interesting, I would say, compromises. Power optimizers work by regulating the voltage and current to avoid mismatch. But after shading, you anyhow lose one string. And here you have to also pay for power optimizers, which increase your capex. With shade-resistant panels, by shading one solar cell, you only lose that solar cell. So the string is still intact and you're not losing current, but you are losing the voltage. So here you need no power optimizer for small to medium sized shades. And again, it brings a lower system cost and higher yield, which again gives a better LCOE. For hotspot-free module, the first version is a successful product, which is on the market since 2018. But now we have an updated version under Hotspot Free 2.0, which is on the way to be unveiled next year. The first prototypes was presented in AESolar 2023. So here my colleagues are doing the same shading scenario, which you saw the video on the new modules, which are made by half-cut cells, and we have invisible bypass diodes, and of course we have less bypass diodes and better functionality. As a takeaway message, I would emphasize that the project owners pay for efficiency and power, so in euro per watt peak, but they need energy. They need euro per kilowatt hours. And hotspot free module gives you more energy per area under shading conditions. In the sense of energy, the module is a flexible module in the sense of shading direction. The module can produce up to 80% more power under STC, and it's shown over 30% higher yield under shading conditions in winter time, which is a low light condition. In the sense of durability, the Smart Hotspot Free module has shown a good durability under stress testing and cycles equivalent to 25 years, which is, of course, was an extra test apart from the general standard tests. And finally, hotspot-free shade-resistant module promises a higher energy yield to achieve a lower LCOE under partial shading conditions. And with this, I would like to thank you very much for your attention, and I'm open for any questions.
Thanks a lot, Hamed. I think you really finished your presentation on dot in time. So sorry, since I have to move to the next presentation, it would be really nice if you can stay and answer the questions in the chat. Of course, there are also some interesting questions on the cost and how you do this interconnection with diode. So really very nice if you can answer these questions in the chat.
Sure. Thank you very much.
Great. Thanks. It was a very nice presentation.